Welcome back as we wrap up this topic on active management with a discussion on the applications and limitations of the fundamental law. Let's get started. First, let's apply the fundamental law to a global equity strategy. For simplicity, we shall use a hypothetical three-market benchmark that's equally weighted between the US market, European market, and Asia-Pacific market with the following active return volatilities. An active manager has a three-point relative scoring system that represents expectations between underperformance and outperformance. He believes the Asia-Pacific market will outperform, while the US and European markets will underperform. The manager wishes to limit active risk to 5% and believes his information coefficient is 0.2. He is taking 3 active bets, so the breadth is 3. Using Grinold rule, the expected active returns of the various markets are as such. Based on unconstrained optimization, the optimal active weights should be as such, and the expected active return for each market should be around 0.58%, totaling to an expected active return of 1.73% for the portfolio. Based on active risk of 5%, the information ratio is 0.35. If we use the fundamental law, we should get exactly the same figures. Let's say the portfolio is constrained such that the manager is not allowed to short. As the reduction in weight for US stocks is greater than the benchmark allocation of 33.3%, the active weight of US stocks should be capped at minus 33.3% to avoid a short position. So let's say the constrained optimization process gives us the following active weights that'll produce the same 5% active risk. The expected active return of the portfolio is lower at 1.58%. The information ratio of this constrained portfolio is therefore 0.32, lower than the optimal IR of 0.35 when the portfolio is unconstrained. Working back, based on the expanded fundamental law, we get a transfer coefficient of 0.91 for the constrained portfolio. Now let's test your understanding. If the manager increases the allowed active risk, what would happen to the expected active return and information ratio of the unconstrained and constrained portfolio? For the unconstrained portfolio, we would expect the information ratio to be unchanged at 0.35, as the information coefficient and breadth are unaffected when active risk is allowed to increase. Therefore, we would allow the expected return to increase proportionally. However, for the constrained portfolio, which follows the expanded fundamental law, the IR is also affected by the transfer coefficient. When the active risk is allowed to be higher, we would expect higher active weights if unconstrained. However, that also means that the constraints are going to be applied more often. For example, if we allow the active risk to be 8%, the weights for both the US and Europe markets will hit constraints. As such, even though active return is higher due to higher active risk, the information ratio is lower. The transfer coefficient has dropped to 0.86 in this case. Before we proceed to the next application, let's briefly touch on some of the shortcomings of the analysis of active performance using the fundamental law. First, the breadth of a strategy is meant to measure the number of truly independent decisions that an active manager makes in a year. If 2 or more decisions rely on same or similar information, then they are not independent. For example, decisions are most likely not independent for fixed income portfolios, as bonds are similarly affected by the same risk factors, like duration risk, so their returns are usually highly correlated. It is likely that manager active decisions on bond allocations are based on the same interest rate outlook, so the decisions are not independent. If individual decisions are correlated, the breadth may be estimated using this formula, where n is the number of decisions and rho is the correlation between the decisions. Similarly, decision independence can be compromised by time series dependency. For example, if we regard monthly rebalancing as active bets, so the breadth is 12, the implicit assumption is that the rebalancing decisions from month to month are independent from each other. However, that is not likely the case, so fundamental law may require some modification to model the correlation in decisions. Another limitation of the fundamental law is that the information coefficient, when estimated on an ex-ante basis, can be, after all, very subjective. Some managers tend to overestimate their ability to outperform the market and hence overestimate their information coefficient. The fundamental law may also be applied to market timing strategies. Market timing is simply a bet on the direction of the market or a segment of the market. For example, an active manager may rotate money in or out of equities to cash based on the expected performance in stock prices. Sector rotation, where the manager sells assets from sectors that are expected to underperform to buy assets from sectors expected to outperform. Market timing strategies is a form of time series application of the fundamental law, whereas security selection strategies, such as the global equity example we went through earlier, are regarded as cross-sectional application of the fundamental law. For example, consider a hypothetical two-sector bond benchmark that allocates 70% to investment-grade bonds and 30% to high-yield bonds. An active manager applies the sector rotation strategy to sell bonds in the class expected to underperform and buy bonds in the class expected to overperform, making such rotation decisions quarterly. The fundamental law should apply, so if the active portfolio is unconstrained, the expected active return should still be the IC times root BR times active risk of the portfolio. However, do note that there are distinct differences in how these parameters are determined for market timing active strategies. Firstly, for a market timer, the information coefficient is based on the proportion of correct calls. For example, if the manager is expected to be correct 55% of the time, the information coefficient is 0.1. Secondly, as noted earlier, the limitation that decisions must be independent when determining breadth. If they are not independent, the breadth is calculated using this formula. For our example, since decisions are made quarterly and assuming a correlation of 0.25, the breadth is estimated to be 2.3. Third, the calculation of active risk should take into account the correlation of returns between sectors given as RXY, calculated using this formula, which you've learned in Level 1. This is the risk for each bet, so if we want to annualize it, we multiply it by the square root of breadth. For our example, let's say the quarterly return volatility of the investment-grade sector is 2.84% and 4.64% for high-yield sector, with an estimated correlation between the two of 0.575. The active risk is 3.8%. Do note that all these here are quarterly figures. Since the breadth is 2.3, the annualized active risk is therefore 5.88%. Using the fundamental law, an unconstrained portfolio can achieve an information ratio of 0.15, and if the corresponding active risk is 5.88%, the expected active return is 0.88%. And this is how the sector rotation strategy can be applied. Let's say the manager wishes to limit annual active risk to 1.76%, which is 30% of the annual active risk. The maximum deviation from benchmark weight he can make is 30%. So if the manager expects high-yield bonds to outperform investment-grade bonds, he can reduce the weight of investment-grade bond to a minimum of 40%, and maximum weight for high-yield bonds is 60%. And that concludes our study on the analysis of active management. Take a break, and we'll see you at the next topic.